This is our EOC review number 7, and we are talking about linear regression, simple linear regression, and finding the correlation coefficient. I gave you some notes on this. It talks about simple linear regression is a statistical method that allows us to summarize the study between two continuous variables, obviously our x and our y. Our x is always our independent, our y is always our dependent variable, so you should know that by now. A correlation coefficient are used in statistics to measure how strong a relationship is between two variables. We are using Pearson's, which is an R. It's the most commonly one used, and that's what we're going to be using it. I also wrote down here that the correlation coefficient between -1 and 1 calculated so that they represent a linear dependence of two variables of the sets of data. A correlation coefficient between 0.8 and 1 indicates a strong positive correlation. If it is between -0.8 and -1, it indicates a strong negative correlation. Then at the bottom of your page, I have the steps to finding the equation and correlation coefficient using your calculator. And we're going to be using those steps, and hopefully before you finish, you'll be able to do those steps without looking, because that's what you're going to need to do for your assessment. What this has is what you saw before in 8th grade was you saw a bunch of, it was called a scatter plot. Okay, and usually your dots, which doesn't look very dotty there because it's hard to see, but your dots, and you had a best fit, a trend line. Do you remember that? A line of best fit. And we would say, in 8th grade, we'd say, well, it has a linear positive correlation, all right, or a linear negative correlation, or no correlation. That was our choices, all right. Well, now we are going to calculate how close that correlation is, and that's what that R is, or that correlation coefficient, all right. Not only do we need to know is it positive or negative, we need to know how strong that data is correlated together. Or if it's weak, it's going to be less than 0.8 or less than -0.8. If it, well, less than -0.8. Well, that's kind of a bad way to say it, because it has to be between -0.8 and -1, which when you're thinking about negative numbers, that's actually a bigger number, right? So a value. Anyway, so we have to have that 0.8 to 1 in order to have a strong correlation. So with that being said, let's look at this data here. Okay. And it says the following table shows the data that was collected. How strong is the correlation of this data? All right, in order to find this, we're going to enter this data into our calculator. All right, so what we're going to do is everybody needs to turn on their calculator. You need to make sure that your calculator is reset. I asked them all from first period, but please do it again now just to make sure. All right. So my RAM's cleared. I'm ready to go. Do you have a problem with that one, Ahad? Okay. All right. So what I'm going to do is I am going to go and follow these steps. It says turn on stat plot 1. So in order to do that, it says push second and stat plot, which is right up above your y = sign. Then if you hit enter, highlight on is being highlighted right now. That's what we want, so we're going to press enter. And to get out of this without changing anything, we're going to hit second and quit, just like when we did with mode to get out of it. Okay? The next thing we need to do, and this is the one thing you need to make sure you remember. Yours is low too? Okay, we're going to wait for you to go get it and get caught up. Ahad, what number was yours?
9.
And what number is yours? 2 and 9. Okay. Okay. Let us know, J. Christopher, when you're caught up. All right. The next thing we need to do is we need to catalog and turn our diagnostics on. So if you notice down here by the 0, on top of the 0, in pink, and mine's in pink, yours is probably in a different color, but you hit second and the 0 key because that says catalog. Okay? Then you go down and you have to arrow down for a while until you find diagnostics on. And there is a diagnostics off and there's a diagnostics on. And you need to make sure that diagnostics on is the one that your arrow is at. Okay, so it's up right there. How many of you have that?
You push diagnostics on.
Okay, once you have the arrow on diagnostics on, it says press enter twice. Do you see right now, even though it says on and it's highlighted, until you press it the second time and you see done, it's not really on. Okay? So the next thing we need to do is we need to enter our data. Okay, so what we're going to do is we are going to go and we're going to hit stat, and then edit is highlighted, so you're going to press enter. We're going to put in the X's under L1 and the Y's under L2. So in this case, we have 1, enter, 2, enter, 3, enter, 4, enter, 5, enter. Arrow over to L2. Press 1, enter, 2, enter, 1.3, enter, 3.75, enter, 2.25, enter. At this point, once you think you have them in, double check them. Okay, because all it takes is for you to put in the wrong data for you to get the wrong answer. Okay, so always go down, double check your X's, double check your Y's to make sure those are in correctly, make sure they're lined up. All right, and to get out of this, you're going to hit stat. Now you want to go over and highlight calculate. Then you need to press number 4 because you want linear regression AX plus B, so 4. Now it is flashing on list. Everybody at the same place I am?
Yes, ma'am.
Okay, all you need to do is arrow down till you get where it's highlighted calculate and flashing on calculate. You're going to press enter and you're going to wait and it's going to do this. So what is this? Let's look at this equation. I have y equals ax plus b. So here it gave me an A value of 0.425, a B value of 0.785, and an R value. We don't care about the R squared. We're looking at simple linear regression. So 0.626 is where I would go. Now remember that everything was so I would come over here and rewrite my equation. Y equals, what is I'm going to roll that to 0.43x. And I've got plus 0.79. My R value is 0.6. That's closer to 0.6 than 0.7, isn't it? So we need to decide what the correlation is. Now, I'm going to write this right here so that you remember. The correlation coefficient needs to be plus 0.8 or above, or negative, it's negative 0.8 or above to negative 1, and we're going to say to be considered strong. correlation coefficient. So with that said, let's read these answer choices. How strong is the correlation of this data? A, there is a strong correlation because the correlation coefficient is positive. Do you agree?
No. Not a strong one.
It is positive, but it's not strong, is it?
No.
Okay, there is a weak correlation because the correlation coefficient is negative.
No.
There is a positive correlation, but is not strong because although it is greater than 0.5, it is less than. All right, so that would be your answer, C. Okay. I think we've defined these down here on our notes. Do you not agree?
Yes.
Okay. All right, so let's flip the page. Says, does the following statement represent an association or a causation? I also want to ask, or no relation. Okay. So we needed to define some terms. I don't know why I didn't get, okay? An association. There is a relationship between two real world variables. In other words, two events are related. Okay? We're going to do causation. One event or real world variable directly causes the other event, real world variable, to occur. Example, cause and effect. The last term, because I don't think I need to describe no relation. Do I need to have an explanation for no relation? No relation would be like hair length and IQ. Is there a relationship between those two? No. So that's no relation. All right. Lurking variables. Are variables that influence the situation and causation cannot be established. So essentially, association just means there's some sort of relationship between the two, but they don't necessarily, one doesn't cause the other to occur. Causation, one definitely and directly causes the other to occur. No association, there's nothing, they don't have anything to do with each other. Lurking variables are variables that influence a situation, and causation cannot be established. So, up here, does the statement represent an association, a causation, or no relation? The number of firefighters at a fire is related to the damage caused by the fire. It's more of an association. The reason, it doesn't say the more firefighters you have at a fire, the less damage you would have. That is certainly a causation, okay? But it's related, but it's not necessarily one causes the other, because they really haven't defined the one and the other too well, have they? So we're going to call this an association. Okay. The data in the table below represents the data of the price of oil to the year. Which of the following can be used to model that data in the table? All right, I'm also going to add an extra question onto this, because that's how a lot of your questions are that you're going to be working at. Okay? The price of oil to the year. Let's say, what is the best prediction of the price of oil in 1996? Okay. Based on the data table that we have, what is the best prediction of the oil price in 1996? Now, first off, when you have years in these tables, you want to make sure and use the first year would be year 0. Okay? Year 1, year 2, year 3, year 4, year 5, year 6, because they didn't establish it to be, because they are going in consecutive order. All right? So, yes, I could find my y-intercept on here pretty easy. I could use y2 minus y1, couldn't I? Okay? Then I could put that in an equation. So, in other words, if I did y2 minus y1, let's say I took these two right here in the middle, and I did 72.77 minus 70.93 all over, this is year 3, and this is year 2, I would get what for my slope? Let's see, 72.77 minus 70.93, I would get $1.84 over 1, wouldn't I? Okay? So then my slope would be 184 approximately. Remember, this is predictions, approximates. All right? How do I find my y-intercept from there? I use y equals mx plus b. If I want to pick a pair, let's say I pick y value of 70.93 is equal to my slope of 184 times x, which would be 2, plus b, and solve for b, correct? Do you remember this? Okay, don't forget these skills in your toolbox, people. So $1.84 times 2 is $3.68. So I have 70.93 is equal to $3.68 plus b. Subtract $3.68 from both sides, and I would get 67.25 is equal to b. So what one would make the most sense to choose? B. I have a slope of 187 and a slope of 67. We know it's not going to be negative. And here is a 2. We know that's way off, okay? So, yes, that would be my most, if I wanted to do it that way. But could I answer this question?
Yes, ma'am.
Probably not.
Oh, never
not accurately. It would take a lot of work. So let me show you how we're going to do it. First off, we already have followed the steps, so I know my diagnostic is on because I haven't reset my calculator, right? And I know my stat plot is on because I haven't reset my calculator. So if I go to stat and hit edit, I've got to redo these. So I'm going to come up here and I'm going to hit highlight L1. I'm going to hit clear and enter. It'll clear everything in the list. Do you see that? I'm going to go over to L2, highlight L2, hit clear and enter. It clears everything in that list. I'm going to come over to L1. Are you doing this with us, Dean? Because if you aren't, you're going to be lost. Okay? I'm going to put these in 0 to 6. Okay? So I've got 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, 5, enter, 6, enter. I'm going to come over and put my L2s in, which is 67. Now this is going to be where it's going to be very important for you to get it right. Once you have put them all in, I want you to double check them and make sure that you have put them in just like they are on the table. Now I should be able to find my A and my B, correct? How am I going to do that? What is the next step?
You go over to calc.
Uh-huh.
And then you go to 4.
Yep.
And then you go down to calculate.
Yep.
And then it shows you.
Then you hit enter. Okay, so here it gave me an A of 187 and a B of 6726. Okay? Ooh, our correlation coefficient is strong, isn't it? And it's positive. Now, what is the price in 1996? If I was to continue this table down to 1996, what year would that be here? It would be 16, wouldn't it? Year 16. So now, I have an equation. Y equals 1.87x plus 6726. Do you agree? All right. I can go to my y equals. I can put in 1.87x plus 67.26 and hit second in table. And I can go down to year 16 on my table, and I can find out it's going to be how much?
97.83.
Do you see how to do that? Have you found it? Ahad? Yes.
Yeah.
Dean, did you get there with us? Or are you still working on it?
Yes.
Okay. So year 16, a barrel of oil is going to cost $97.18. So this is how we predict. This is how statistical people predict things for our future. What's going to happen to the price of this and what's going to happen to the price of that. Now, there's always those lurking variables that may change things, but that's basically how they come up with that. All right, we're going to do a few of these together, okay? And one for Sierra, please. And one over that way. I'm going to give one for Kendall.
I didn't accidentally clear mine. So.
All right. All right. Everybody have one? The first thing I need you to do is I need you to go on page 97 and cross off number 3. Okay? Then you're going to go to page 101 and cross off number 3. And page 105, cross off number... 101, cross off page... Page 101, cross off number 5. Okay. I wish I could do more, but I'm not going to. So, we are going to go, the first place we are going to go is we are going to go to page 101. And we're going to read number 2 together. It says, Sam's mom claims the number of hours spent playing video games brings down his grades so that he should stop playing video games. Is she claiming an association or causation? Really, I agree. Causation. And I'm not going to make you explain. Okay? Number 3. Number 3, we're not doing. Number 4. The principal of an elementary school noticed that there was a correlation factor of positive 0.89 between students' shoe sizes and their show sizes and their reading scores. She concluded that instead of spending time and money giving reading tests, she could use shoe sizes to evaluate their reading ability. Is the principle valid?
No.
So is there a relationship?
No.
Oh, okay. No relationship. Wesley, read number 5.
I thought we don't do number 5.
What are you doing? Who is it? Well, you better give it to him. Happy birthday.
Oh, thank you.
Late, but happy birthday.
I thought we didn't do number 5.
Oh, we don't do number 5. Let's flip the page. All right, here we go. Here I thought she wanted me. A soccer coach graphed the data of time his players spent in practice and the goals of the goalie saved. Which of the following statements did his data show? So the soccer coach graphed what?
The time his players spent in practice and the goals.
Right. So the players, not the goalie, the time the players played in practice and the goals the goalie saved. Which of the following statements does this data show? What?
None of these.
Very good. None of the above because it doesn't have anything to do with, right? Very good. Okay. All right. 7. I'm going to do 8. A survey showed that sleeping with a nightlight was positively associated with nearsightedness.
What
Is this an association or a causation? Thank you. It is an association. That's why I chose to do that one with you. Okay. A study showed a positive relationship between students owning a cell phone and driving a car to school. Is this an association or a causation?
Neither.
No, it's an association because if they own a cell phone, they probably have more money, so therefore they drive to school, right? But it's not directly related.
What if you don't have a cell phone? You drive a car.
I'm going to let you do the rest on your own. Let's turn the page to 105. Okay, so I got better at doing my explanation because 105 you needed that second piece on the show and tell there in order to do. Alejandro purchased a painting in 1996 for $250. In the year 2000, the painting was worth $370. If the value of the painting continues to increase at the same rate, how much will the painting be worth in the year 2010? So, here we go. We have 2 sets of data. We have year and we have dollars, right? So 1996, he purchased it, right? So what year is that? Year 0. Okay. How much is it worth? Okay. Then in 2000, which is year what? 4. It was worth what? $370. So 2010 is going to be what year? 14. So you're going to need to find out how much it's worth. So what are we going to do? The first thing we have to do is find our what? Equation. So we need to find our A and our B, right? So what are we going to do? Stat. Okay, so we're going to press edit, and then we're going to have to clear our L2 and our L1. And I'm telling you, the easiest way to learn to do that is highlight that L1, hit clear enter. Then you don't have to do each one individually. Okay, so I've got year 0, year 4. And then we go to L2. Don't tell me you fixed it.
It's a 3-hole punch now.
What?
It's a 3-hole punch now.
You are awesome.
I took this punch, put it on here, here, and here. I took this one out.
I don't want to use the 2-hole anyways.
And
Oh my
this is
gosh.
what happens. There's a little drive mechanism. This hooks onto here,
Uh-huh.
like this,
Uh-huh.
and it sits on top of a low cam,
Uh-huh.
and it keeps it engaged. This was weld here.
Oh, so it broke.
Yeah, this is supposed to be this long. So there's a screw that holds that one in.
You are
And I took this one out and I put it over here.
You are awesome.
So
Thank you so much. Oh my goodness. Oh my goodness. Thank you so much.
No problem.
Oh my goodness. All right, L2, what do we put? 250 and 370. All right, so now what do we do? Stat, calculate, 4, down to calculate.
Enter.
What do you get?
30x plus 250 and enter it into your y equals, and you hit second table, then you go down to 14.
30x plus 250, hit second table, go down to 14, and what is it?
It's
6
600.
and 7.
All right, so you get how to do that?
Yes. Simple.
Okay. Now, what I'm going to tell you is here. Okay? You've got year 3 for 25. You've got game 7, for 60. Okay? All right? And so remember that you're not always going to be exact. Okay? You're going to be picking the closest. Up here, when it goes to years, make sure that you're taking your first year of 1998 at year 0. Okay? And so that would be 0 over here, and then he's got year 2000. That's year 2, 75,000 miles, right? And then they want to know when he will be at 300,000. So now you're going to be looking for your X value when you go to look at your chart. Does that make sense?
Wow.
Okay. On number 5, something that's tricky. Okay. Instead of after, that word after on number 5, please make this change. You are going to write at. Okay. And the other thing is if you are doing 4 feet 6 inches, you either need to do 4.5 or you need to convert all of this to inches. Now, it's going to be hard when you get to 6.2. That's 1 1/6, right?
Right.
So so my suggestion is that you convert to inches and then convert your answer choice back out to feet and inches. Okay? The rest is pretty simple. You should be okay with it. Do you want me to do one more?
Yes, ma'am.
Which one do you want me to do?
It doesn't matter. The hardest one. 5.
Oh, you little.
Oh, please
Toots.
don't do that one, Miss Lloyd.
Steve planted a tree in his backyard that stood what? So at 0 years, it was 54 inches. After 2 years, the tree had grown to 74 inches. If the tree continues to grow at this pace, what is a reasonable projection of the height of the tree in year 9? Oh, come on, we can do this. Go to stat, edit.
It goes 10.
What?
It goes 10 inches every year.
So then we have 0 and we have 2. And then we over here, we have only got 2 numbers. We have 54, enter, and 74, enter. So stat, calc, for, all the way down to calculate. Hit enter. I get an A of 10 and a B of 54. So go back to my y equals. Put in 10x plus 54. Second graph. And at year 9, I'm at 144 inches. Divided by 12. Clear. 144 divided by 12. B. Okay, so that's not hard, is it? Okay? All right.